So hi everyone, my name's Alistair Spears. My team's responsible for service operations. So we do things like capacity planning, life cycle of launching new features, geo expansion. So if you've ever seen the products by region page or the roadmap pages, our team works on those. Crisis communications, incident management, incident communications, and those sorts of things. Just a quick show of hands, who saw Sammy's session right before this over in Theater 5? Okay, a couple of people. Yeah, so this is kind of the counterpoint to Sammy's session. We work very closely together between my engineering partner, Sammy, and really the goal for this session is to correct all the mistakes that Sammy made in his. So, 99.998%. This is a historical average VM uptime. It changes. There's a couple of things you'll notice here. It's not 100%, and that's a big challenge for us. Every day we come to work thinking about how we can add more nines into the core environment in Azure. This equates to an average of about 10.5 minutes a year of downtime for a particular virtual machine. But these are the lives of averages, right? No server, or not all servers don't see 10.5 minutes of outage. Some servers see more, some servers see less. And so it does kind of hide some facts there. And so as we start to approach this 4 nines, 5 nines, 6 nines of availability on particular services, we start to ask ourselves different questions of how do you go beyond availability to really understand the customer impact? 10.5 minutes of downtime or 10 one-minute outages? I mean, which one would you prefer? And so that's where we've started to measure what we call our annual interruption rate. An annual interruption rate is essentially measuring much more of a customer experience of how many interruptions do you have. You know, a 1-minute blip on Microsoft's host server or host network could cause an hour of outage on the system that's built. If you've got unexpected restarts, I mean, who knows what goes on in client guest machines that are sitting on top of Azure when they see an unexpected restart. And so we feel it's very important for us to start to track this annual interruption rate. And you can see that we've made a lot of improvements over time. Back when the Spectre Meltdown vulnerability came out in Azure, that caused us to do a hard reboot of all of our systems. And so essentially we had almost 100% of virtual machines seeing a restart 2 years ago, almost 2 years ago. Now, the improvements we're making and the improvements we'll talk about this week, we're expecting to get down to an annual interruption rate of about 3. So 3% of servers will see restarts caused by outages in Azure is our goal. Of course, our goal is less than that, but that's our near-term goal that we're aiming for as well. So how do you prevent that? Well, that's just a core VM, a single VM sitting there doing nothing, running in Azure. And of course, we don't offer a 5 nines SLA for a VM just sitting there like that. But we do offer a 3 9 SLA using premium storage. And so premium storage is a feature that you can use to essentially make sure that that virtual machine's running on multiple hard drives. It protects you from a single disk failure. As you think about availability sets, you're really preventing kind of a rack level failure in the data center there, a whole rack or a unit of compute inside of our data center. And using availability sets, we'll offer a 3.5 nines availability. All the way to availability zones, spreading and protecting yourself against full data center failure. We can offer a 4 nines SLA as well. So these are all features, capabilities, resilient services that you can use and build into your own applications to help beat the average uptime that Azure provides. But of course, that's stuff that you should do. And this week, there's a lot of sessions to tell you all the things you can do to improve how you operate Azure. Tomorrow, we have an ops learning path. The whole day will be filled with reliable architecture sessions and operations sessions, so that's a great day. We also have a bunch of other sessions here as well. But for the remainder of this talk, I'm really going to talk about this last thing. What is Microsoft doing? What are the investments that we're making to make Azure more reliable for everyone running on top of that platform? So one of the things we're doing is scale, building more and more systems, more and more regions, more and more capacity within our regions, and more connectivity to all of our data centers around the world. We operate around 54 regions worldwide. There's about 100,000 miles of fiber cable that Microsoft owns and operates that's connecting all of these regions around the world. There's 135 edge sites. These are kind of the edge of our network that customers peer to or telecommunication providers peer to. So that if you're communicating to one Microsoft data center, you're on the Microsoft network, and we manage that traffic and route that traffic around issues anywhere in the globe. And of course, we have 200 express route partners that can guarantee connectivity into those edge nodes and onto the Microsoft network. So the dirty secret about the telecommunications network was it was following the telecoms network, which was following the telegraph network. And so the same route that we use today to communicate data between North America and Europe also communicated the outbreak of World War I over the telegraph, between North America and Europe. And that poses a problem. That's not a very resilient network. There's not many other connections across the world. And so at Microsoft, we've started to build redundancy into our continental fiber connections as well. And so this boat here is laying our new cable, our Maria cable, that's linking Virginia to Spain. And so that essentially gives us an alternate route of traffic into Europe from the previous ones that generally go from New York into London or Dublin. And depending on how you look at it, maybe the only connection to Europe if Brexit happens as well. So once you get that traffic there, let's look at the regional networks. And essentially a region is the sort of scale of compute that you're starting to look at through the Azure portal. We don't surface data centers. You can't pick a data center that you operate inside of Azure. You pick a region. And so what is a region? Region's a set of data centers. What's unique to Microsoft compared to other clouds is that all of our regions are on that same global Microsoft WAN backbone. So connecting all of our regions together is our own fiber network connecting these things together. And of course, express route partners and internet peers also come in through that same edge into our Microsoft WAN. From the WAN, Microsoft runs a set of regional network gateways. You can think of these as data centers for networking, essentially software-defined networking appliances that are managing traffic and coordinating traffic to all of the data centers within that particular region. Now, a region is made up of multiple data centers, and these data centers are grouped together in availability zones. What you know from this diagram is that each one of these data centers has a redundant connection to the regional network gateway as well. The nice thing about this model is it allows us to scale really easily. We essentially can add more data centers, more availability zones into a region without having to connect every data center to every other data center as well. So the simplicity of the design here really gives us a lot of fault tolerance as well as an ability to scale. If you're interested in this, Mark Rusinovich does an awesome job of talking more about our infrastructure architecture and our data center architecture. He'll be doing that talk Thursday at 2:15. You'll probably want to start lining up about midday because that session gets really popular really quickly. So how do we make changes? Change is a big cause of pain in Azure and in any sort of software development. Like the old way of doing reliability was locking it down, change freeze, change advisory boards, ITIL frameworks, gold master disks, locking the doors, all of these sorts of technologies to restrict change. We don't have that ability in the cloud, and I would argue that even that old approach to change management by preventing change didn't give us more reliable systems in the first place anyway. It just meant that people would stop following the processes and sneak changes in. I see a lot of nodding heads, so I'm sure many of you have worked with developers before. So how do we do that? How do we fix that approach? How do we embrace that change and automate it? This is essentially a very high-level view of Azure's DevOps pipeline. We didn't call it a DevOps pipeline because we didn't think that far ahead. We should have called it a DevOps pipeline, then it would be cooler. We call it our safe deployment practices. And this safe deployment practices is a set of automated gates that makes sure that when we have an outage, we don't have to write those dreaded words that say, an engineer made a change, and we rolled back that change, and we fixed the issue. That's the most hated root cause analysis or a post-mortem document that we get to write, because essentially it means that we didn't catch it early enough, we didn't catch it in testing, And we've set up a number of gates here to make sure that doesn't happen. So dev and test, it's the developer playground. They can do whatever they want in our environment. They can build releases, and they can also build private previews. So these preview environments that can give out to customers or other vendors or teams inside of Microsoft to use and get feedback. But once that private preview is passed, they put it into our staging environment. And from the point of that staging environment, the developer is on call. This is now live. This is a production system as far as the developer is concerned. Once it passes our staging gate, it'll go to our early user access program. This is a kind of a dog food environment. We have first-party customers like Xbox, Office, and even some other large customers that have signed up to run environments in this particular environment here as well. And again, we collect telemetry here and understand that environment. The next step, which is a little bit unique from a DevOps pipeline, is essentially a hardware diversity pilot. We have a lot of servers. We have a lot of different servers, and we've been building these servers for many, many years. And each server functions a little bit differently. There are quirks, there are tweaks with different generations of hardware, different generations of processors. So we essentially have an automated build environment that spreads that particular code change out over those environments so that we can gather telemetry and see how it is functioning on various different environments. Passing that, essentially our pilot environments, our early region environments. And once it hits an early region, that's when you'll start to see us talk about it as generally available. This feature now has an SLA, it has a production SLA applied. Finally from there, once we've used an early region, we'll essentially do a broad rollout to patch the paired region. And so each one of our regions is paired, so if you do need geo-redundancy, we're making sure that we don't patch that same environment at the same time. Through all this environment, we're generating a whole lot of log files. And for those that have run on-premises servers, log files are pretty useful for filling up hard drives. Then you delete them, and then you start again. But in Azure, we tend to capture all of these log files from the Azure services, from the infrastructure, even from the hard drives generating telemetry about the speed of reads and writes, bad sectors, bad clusters, from the infrastructure like fans, heat, cooling, electricity usage, and then also telemetry from Office, Bing, OneDrive, Xbox, and all of the Azure services that are built on top of our pipeline. And finally, customer support. And Twitter. It's amazing that social media now is far more faster at sending a signal around an issue or an outage, and people generally now, especially developers, will complain on Twitter before they will complain to our tech support. And so that's now an important system in our telemetry tools. So all of this data gets munged into something we call the Azure Brain. What is it? It's a really big database. It's essentially a Cosmos database, and tools like Cosmos, Custo Query Language, and Azure Data Explorer were really invented to solve the need that we had inside Microsoft to deal with all this log data. Exchange alone generates something like 24 petabytes of log files every 24 hours. So there's a lot of data here that gets generated from these systems. And collecting that information together gives us the ability to start to run anomaly detection, machine learning models, and then automated response systems on top of this. And finally, you see the kind of outcomes of that through our automated notification systems, through things like Azure Resource Health, Azure Monitor, the Service Health Dashboard. It also engages our on-call engineers where needed, or even carries out automatic remediation capabilities. How am I going to? So once you have that data, you can build AI models. And without the data, without the logs, without the historical understanding of how your system operates, it is very hard to do machine learning on top of that infrastructure. And so self-learning, big data analysis, this telemetry pipeline, detecting issues, identifying early warning patterns. Now we can detect hard drive failure, for instance, 4 hours in advance of when that hard drive will fail. Because we've seen the way those hard drives fail, we can identify that certain manufacturers have certain mean time between failures, they'll burn out in certain ways. There's certain warning signs, like bad clusters, and a certain amount of bad clusters that we start to see indicates an imminent failure of a drive. And so now our systems are smart enough to essentially automate live migrate anything running on those particular hard drives off production, and then start burn-in operations on top of that as well. So this is kind of the base level stuff, the resilient foundation that we're building into Azure. Like, this is the stuff that improves that baseline. If you do nothing in Azure, if you take advantage of none of the high availability services, if you're not using site reliability engineering practices, if you haven't built a resilient architecture, you get this for free. But that's not enough, and your system, it's a shared responsibility. We need to choose the right resilient services to deliver that appropriate level of uptime. And I think that's probably one thing that's really important, is that not everything has to run at 100%. It's expensive. It's expensive from a cost point of view. It's also expensive from a personnel point of view, for you to be on call 24/7, reacting to changes like this. So understanding what the right level of availability for the different applications and workloads you're running inside of your business, really critical. And then finally, your application that you build on top. So a couple of recommendations here. One, understand how we build and how we architect Azure, because it can influence the design choices that you take with your architecture. You know, it's not the same as AWS, it's not the same as GCP, it's not the same as Heroku, or even an on-premises architecture. So understanding how Azure is built can help you choose the right architecture for your applications as well. Use service health alerts. Use our scheduled events and define your own service level objectives for your application, so that when something does go wrong, you're notified appropriately and your systems are built to understand what's coming out of that Azure brain in real time. Take advantage of high availability, disaster recovery, and backup services. And don't reinvent the wheel. Like, Azure's been going for 10 years now. We have great best practices, patterns and practices of how to build reliable applitions for your particular needs as well. Tomorrow is a big day for ops engineers and site reliability engineers. If you're interested, at 9:15 tomorrow, we'll essentially start walking you through what we call the Dickerson hierarchy of reliability. You know, starting with monitoring. Monitoring is the key thing if you're looking at reliability. If you don't have great data, you don't have great reliability. Incident response, post-incident review, testing release, and capacity and scale. So definitely come along tomorrow. Look forward to seeing you there bright and early at 9:15 in W415C and D. And with that, thank you very much for your time. I'll open up for questions. Cheers.